All right, time for the last video of this section. Both of these are really important examples to look at, and we'll talk about why. So for this first one, I guess it's maybe not as important. The second one is really important. Alejandro needs to make both the horizontal and vertical supports for a ramp. Is one 12-foot board long enough for both supports? Well, this is fairly easy because I know that the hypotenuse of this triangle is 10. And I know that it's a 30, 60, 90 triangle. So I can use the relationship we just learned before and take this number and say, okay, I know that this is 2x units long. And that means that this is 1x units long. It's going to be half of that. And then I know that AC is going to be x root 3 or 5 root 3 units long. And that means that if I add 5 plus 5 root 3, all I need to know is that it is less than 12. So let me do that real quick. You guys, I have no idea how you use these iPhone calculators. They're so difficult. Let's see, the square root of 3 first times 5. There we go. So this is 5 plus 8.66. Add those together, we get 13.66. That is longer than 12 feet. So one 12-foot board is not long enough. To make both those horizontal and vertical supports. In this other one, we have a square piece of origami paper, and it is folded with a 200 millimeter diagonal fold. We want to find the side length and the area of the paper. Well, I can tell because this was a square, and I bisected two of the angles, that makes them 45 and 45, and this is 90. So this is a 45, 45, 90 right triangle. But we are used to seeing 45, 45, 90 right triangles where we have x, x, and x root 2. Here, 200 is not anything root 2. It's just 200. So this is the side we would normally call x root 2. What do we do when it's just a number? Here's what we're going to do. We will say that the x root 2 side equals 200. And then from there, we can go ahead and we can simplify. So if I want to solve for x, or in this case it would be s because it would be the side length of the square, I could divide by the square root of 2 on both sides. And that would give me x equals 200 over root 2. But of course, we learned that we can't have a square root in the denominator of a fraction. So we're going to need to rationalize this denominator, which means I'm going to multiply by root 2 over root 2. And that's going to give me 200 root 2 over. And then on the bottom, root 2 times root 2 is just 2. 200 root 2 over 2 can be further simplified because 200 over 2 is the same thing as 100. So we can call that 100 root 2. That can be the side length of our square. There's a pattern in there. I'm not going to go into the details about it. If you can figure out the pattern for when you have a whole number here rather than a square root of 2, feel free to use it. Otherwise, you can rationalize the denominator every time to find the side length. So now that we know the side length, we want to find the area of the paper. Easy enough, right? We just take 100 root 2, and since it's a square, the side length squared is the area. Square both pieces there. 100 squared is 10,000. And then the square root of 2 squared is 2. So the area will be 20,000 what? Millimeters squared. But yeah, the thing to keep in mind about this example is how do you do something when you don't know what the x root 2 side is, or if you are doing a right triangle that was a 30, 60, 90, maybe you have a whole number right here on the x root 3 side. You can do exactly the same process as this one to find the length of the x side and then go from there. So hopefully this is enough information to get you started on the assignment for this section.